Today in this class, I shall be discussing about semiconductor electronics. I will start a new chapter which is semiconductor electronics. So today's topic is semiconductor electronics. So here in this chapter, we shall be first discussing about semiconductors. So semiconductor is actually a type of material. Is a type of material from which different types of electronic circuits, different types of electronic devices such as diodes, transistors, all these devices are made from a particular material which is known as semiconductor. So first of all, we have to know about semiconductor. What is a semiconductor? So the discovery of semiconductor has actually revolutionized the electronic system in our day-to-day life, because by using this particular material, different types of digital circuits can be made, and these digital circuits are used in our, for example, in our mobile, in our laptops, in our computers, in our TV. So the discovery of this particular material is very much important in our day-to-day life. So first of all, you have to know what is a semiconductor. So semiconductor is a particular type of material whose conductivity is less than conductor. Jar conductivity to conductor ke kom thake, kintu insulator ke bechi thake. So what is a conductor? Conductor is that something through which can conduction of electrons can easily take place. So what is a conductor? Conductor is something through which the flow of free electrons can take place easily. So those such materials are known as conductors. And what is insulator? So suppose this is a conductor. What will happen here? So there is abundance of free electrons in this particular material. And if you apply a potential difference across this conductor, this free electron will be drifted. This free electron will be moving throughout the circuit. If you apply a potential difference, suppose this is positive and this is negative, these free electrons will be drifted throughout this conductor or in this circuit, and which will create a particular current. So this is all about conductor in which there is abundance amount of free electron. Okay. Now there is one more type which is insulator. So insulator is such material, and it was an electron material that কোনো free electrons নাথাকে, কারণ ইয়াত থকা ইলেক্ট্ৰনবিলাক ফ্ৰী হ'বই নোৱাৰে। গতিকে যদি ইয়াত মই এটা পটেনশিয়াল ডিফাৰেন্স দিওঁ, তেতিয়া আউটাৰ সাৰ্কিটত কোনো ধৰণৰ কাৰেন্ট নাপাওঁ, বিকজ ইয়াত ফ্ৰী ইলেক্ট্ৰনে নাই। আৰু এই কাৰেন্ট পাবৰ কাৰণে সদায় ফ্ৰী ইলেক্ট্ৰনৰ কি লাগিব? এটা মোচন লাগিব, ফ্ৰী ইলেক্ট্ৰনৰ ড্ৰিফ্ট হ'ব লাগিব। So insulator is something through which we cannot obtain any electric current. So in between these two, there is another material which is known as semiconductor. So semiconductor বুলি এটা বস্তু আছে, এটা material আছে, যিটো conductor আৰু insulator কে অকমান বেলেগ. It is different in the sense that the conductivity of this material, when a potential difference is applied across the two ends, is smaller than the conductor but more than the insulator. গতিকে ইয়াৰ কণ্ডাক্টিভিটিটো ইয়াতকে কম, কণ্ডাক্টৰতকে কম হ'ব, কিন্তু ইনসুলেটৰতকে ডেফিনেটলি বেছি হ'ব। So that is what you can say. In semiconductor, there are some amount of free electrons, though the quantity of free electrons may be smaller than the number of free electrons in a conductor. Conductor তুলনাত ইয়াত থকা free electrons বিলাক definitely কম, কিন্তু ইয়াত free electrons থাকিব। গতিকে এই পার্টিকুলার মেটেরিয়ালটো কি বুলি কোৱা হয়? সেমিকন্ডাক্টর, যার কন্ডাক্টিভিটি কন্ডাক্টরতকে কম কিন্তু ইনসুলেটরতকে বেশি। কারেন্ট কন্ডাকশনটো ইয়াত কিছু কম পরিমাণ পোৱা যাব। ওকে, so now here we shall be now discussing about only semiconductors. এটা আমি ইয়াত বৰ্তমান semiconductor ওপৰত শিকিম। First of all, you have to know about a concept, or basically there are two terms which is involved in any kind of solid, whether it be a conductor, whether it be a insulator, or it be a semiconductor. Eta particular দুটা term use হয়, যি দুটা termক কি বুলি কয়? Energy band Actually, there are two types of energy band. One is conduction band and one is valence band. এই কথাখিনি আমি ইয়াত ডিসকাস কৰিব লাগিব. So first of all, we shall be discussing about energy band. Energy bands in a solid or in a solid. And this solid is now classified into how many types? Three types: conductor, insulator, and semiconductor. So first of all, we shall be discussing about energy band. Now, what is energy band of any solid or any solid material? So since we are discussing about semiconductors, যেহেতু আমি বিশেষকৈ semiconductor ওপৰত ডিসকাস কৰি আছো, মই semiconductor ওপৰত ভিত্তি কৰি energy band diagramটো বুজাবলৈ চেষ্টা কৰিম. Okay, এতিয়া I will be explaining this in a very simple manner. গতিকে ইয়াত মই energy band একদম এটা simple manner একদম সিম্পল কে বুজাম আৰু কিছুমান কিতাপত বহুত কমপ্লেক্স ওয়েট থাকে আমি ইমান কমপ্লেক্স ওয়েট যাব দৰকাৰ নাই সো উই জাস্ট নিড টু নো হোৱাট ইজ এনাৰ্জি ব্যান্ড এন্ড হোৱাট আর দি টাইপস অফ এনাৰ্জি ব্যান্ড এই কথাখিনি আমি ইয়াত জানিলে হ'ল বা কি কেনেকৈ এনাৰ্জি ব্যান্ড সৃষ্টি হয় সো ফ্ৰম দি পইণ্ট অফ ভিউ অফ সেমিকন্ডাক্টৰ আই উইল বি এক্সপ্লেইনিং দ্য এনাৰ্জি ব্যান্ড অফ এ সলিড এটা কি হয় সাধাৰণতে as for example the most abundantly found semiconductors are most commonly used semiconductor are actually silicon and germanium. It is the most abundantly used semiconductors. It is silicon and germanium, and both are tetravalent. Now, tetravalent element means the atom of silicon or germanium has 4 valence electron. তারমানে outermost orbital এই দুটা এটমত 4টা ভ্যালেন্স ইলেক্ট্রন থাকে এখানে হয়তো কেতিয়াবা কি কয় টেট্রাভ্যালেন্ট এলিমেন্ট গতিকে ইহঁতৰ যদি মই ইলেক্ট্ৰনিক কনফিগাৰেশনটো চাওঁ তেতিয়া আমি দেখা পাম যে সিলিকনে হওক বা জার্মেনিয়ামে হওক আউটাৰমোস্ট অরবিটত কেইটা ইলেক্ট্ৰন ঘূৰি থাকিব 4টা সো ধৰি লৈছো এটো এটা সিলিকনৰ এটম এটা আইসোলেটেড এটম অকলশৰীয়াকৈ থকা এটা এটম এতিয়ালৈকে ই ক্রিস্টাল ফৰ্ম হোৱা নাই এটা মই জাস্ট সিলিকন এটা এটম লৈছো আৰু তাইটো ভ্যালেন্স অরবিট ভিতৰত অরবিট বিলাক আমাক দৰকাৰ নাই we are just concerned only about the valence orbit or the outermost orbit আৰু এই outermost orbit আমাৰ কেইটা ইলেক্ট্ৰন আছে 1 2 3 4 চাৰিটা ইলেক্ট্ৰন আছে for this isolated atom of silicon in this isolated atom of silicon there are how many valence electron 1 2 3 4 because it is a tetravalent element এটা কি হয় we know any electron which is revolving around a nucleus or in an atom all these electrons possess two types of energy one is kinetic energy and one is potential energy so sum of these two energy will give the net energy of these electrons okay so প্ৰত্যেকটো ইলেক্ট্ৰনৰ ইয়াত kinetic energy আছে আৰু potential energy আছে আৰু kinetic energy কেলে আছে because all these electrons are in motion so anything which is in motion will always possess kinetic energy গতিকে প্ৰত্যেকটো ইলেক্ট্ৰনৰ একোটা নিজৰ kinetic energy আছে এটা প্ৰথম কথা নেক্সট লগতে আৰু কি এনাৰ্জি আছে পটেনশিয়াল এনাৰ্জি কি কাৰণে পটেনশিয়াল এনাৰ্জি আছে বিকজ some work has been done by these electrons to keep themselves away from the nucleus nucleusৰ পৰা আঁতৰত পজিশন কৰিব কাৰণে এই ইলেক্ট্ৰন বিলাক এটা ওয়ার্ক কৰিব লগা হৈছে যাৰ কাৰণে প্ৰত্যেকটো ইলেক্ট্ৰনে আৰু এটা এনাৰ্জি গেইন কৰিছে এটো পটেনশিয়াল এনাৰ্জি so in other words it has got two types of energy one is the potential kinetic energy due to which motion and another one is the potential energy due to the work done to position itself from the nucleus at a certain distance আৰু আমি জানো যে এটা নিউক্লিয়াস ইলেক্ট্ৰনৰ পটেনশিয়াল এনাৰ্জি দুটা চাৰ্জৰ মাজত সাপোজ এটো এটা পজিটিভ চাৰ্জ আমি জানো নিউক্লিয়াসৰ পজিটিভ চাৰ্জ and this is the negative charge দুটা চাৰ্জৰ মাজত পটেনশিয়াল এনাৰ্জি ফৰ্মুলা কি আছিল 1/4 pi epsilon naught q1 q2 by only r this is the potential energy between two charged particles here in this case it is the nucleus and it is the electron the potential energy between these two particle is this one okay আৰু দেখিলো যে এই পটেনশিয়াল এনাৰ্জি টু কাৰ ওপৰত ডিপেন্ড কৰিছে ৰেডিয়াছৰ ওপৰত এতিয়া কি হয় এটা কথা ঠিক যে all these four electrons have got the same kinetic energy because all these electrons possess the same amount of speed in a particular orbit যেতিয়া এটা particular orbitত ঘূৰি থাকে প্ৰত্যেকটো ইলেক্ট্ৰনৰ স্পীড বা ভেলোসিটি সেম ওটকে তাৰ kinetic energy তো সেম all these four electrons of this isolated atom is having same kinetic energy next kora potential energy to ki etia prottektu electron same na different the potential energy is also same why because the distance of each of these valence electron from the nucleus is also what same So distance of would depend on the distance to same, charge to the same, q1 q2 same. So definitely the potential energy of each of the valence electron is also same. So from this we have learned that each of the valence electron of this isolated atom of silicon has got same total energy, because total energy is the sum of this energy and this energy. Kote protect valence electron total energy same. Ketia only when the atom is in isolated state. Okol koreke jetia thakibo tat thaka protect valence electron or total energy to same. Kintu if the same atom forms a crystal, at a solid body jodi form hoy, solid body form howa mane ki eta atom na thake ta billions atom itu by to interact koribo, billions, it is a collection of billions of atoms. So whenever the same silicon atom forms a crystal, something will happen now. What will happen? Now a crystal has been formed and this is a silicon atom and there is a number of silicon atom and each silicon atom is having a each of the silicon atom is having 4 valence electron. And yet it silicon atom and all these silicon atoms are forming a crystal, so they position themselves in this certain lattice point. So a lattice point bilakot a silicon atom bilak dhuniya ke bohi ase. Eto eta silicon atom, eto eta silicon atom, tenokot billions of silicon atom nijor lattice position hoy ase eneke, and together they form a crystal. Aru ki dekhilo protecto silicon atomor eta 4ta ki electron ase, valence electron ase, because they are tetravalent. So ei blak amor 4ta valence electron maki dis. Okay, etia ki hobo tenoko billions of silicon atoms ase, moi yat tenoko 5ta silicon atom dhoi loise. Etia what will happen? We know from octet rule that any atom to gain stability they want to have 8 valence electrons in the outermost cell. Outermost cell kuno eta atom stability gain koribo karone total keta electron lobo bisare 8ta. Kintu a particular silicon to keta ase 4ta, tane 4ta short hoy ase. Gotike ei 4ta electron hi pabo karone stability gain koribo karone aru 4ta lage, ei 4ta electron kobo pabo ei kakhot thoka silicon atom bulakor valence electron bilakor logot share koribo. This atom will now as a whole will share 4 of the valence electron of the neighboring silicon atoms. Aru hei sharing korato ki boli koy covalent bonding boli koy. Gotike ami ki dekhilu je yak eta covalent bonding hobo, aru covalent bonding howa mane ki electron bilak share hobo. Share howa mane ki ei electron to ei atom to side phale ghuribo ba nucleus to side phale ghuribo, plus ya aru ta kam hobo je ei nucleus to side phale ghuribo. Similarly ei electron to ei nucleus to side phale ghuribo plus ei kakhot thoka nucleus to side phale ghuribo. Eituke koy covalent bonding boli koy. So eta majo electron share hobo, aru he share kora karone ki hobo, ultimately they will get a share of total number of 8 electrons and the stability will be gained by all these atoms. Tenoko sharing protect atome kakhot thoka silicon atom bilakor logot bonding form koribo aru etu covalent bonding koy. Gotike etu eta covalent bonding hol. Okay, so etu eta covalent bonding hol, etu yar logot share korile iu yar logot share hol. Gotike etu eta covalent bonding etu, so yar kisuman covalent bonding hobo. Teneke protecto crystalot teijone ei protecto atome eto valence electron kakhot thoka silicon atomor valence electron bor logot eta covalent bonding create korise, eta strong covalent bonding. Covalent bonding mane share korise. Ei eneko dhoroner covalent bonding hoy ase dei, মই এনেকা দেখাই দিছো. Okay, এই বস্তুটো হবো এতিয়া. Okay, jetia eta silicon atom goi pele enaka ta crystal form koribo, gute billions atom bore kakhot thoka silicon atom bor hoite electron share koribo aru he sharing to ami at ki boli kau covalent bonding kora boli koi. Okay, etia ta kotha hol, etia muk suppose etia a atom to 4ta valence electron, similarly a atom to 4ta valence electron, teneke a atom to 4ta valence. Etia muk kotha hol je ei protecto valence electron ebar energy total energy same থাকিব না different থাকিব. যেনেকে isolated atom ক্ষেত্ৰত কি দেখিছিলো প্ৰত্যেকটো 4টা valence electronৰ total energy same আছিল. কেলে same আছিল? প্ৰত্যেকটো kinetic energy same, লগতে প্ৰত্যেকটো potential energy same. Potential energy কেলে same? কাৰণ প্ৰত্যেকটো valence electron এই particular nucleus টো পৰা same distance ত আছে, এইটো distance r is same. So when this r and q1 and q2 are same, the potential energy is also same. হেতু আসলে ইন এ কেস অফ এন আইসোলেটেড এটম কিন্তু যেতিয়া এটা ক্রিস্টাল ফর্ম কৰিলে কি হ'ব এই ইলেক্ট্রনটো কেবাটাও নিউক্লিয়াসৰ ইনফ্লুয়েন্সত আহিব this electron suppose I am taking this as the first electron এই ইলেক্ট্রনটো এই নিউক্লিয়াসটো ইনফ্লুয়েন্সত আছে লগতে it will be influenced by this nucleus also and this nucleus also because they are at a certain specific distance from the each nucleus গতিকে এই ইলেক্ট্রনটো অকল ইয়াৰ লগত ইন্টাৰেক্ট কৰি থকা নাই এই নিউক্লিয়াসটোৰ লগত ইন্টাৰেক্ট হোৱা নাই হ্যাঁ ইয়াৰ লগত ইনফ্লুয়েন্স ইয়াৰো আছে গতিকে কি দেখিলো আৰু এই ডিসটেন্স বিলাক বেলেগ বেলেগ এই ইলেক্ট্রন টু ইয়াৰ পৰা এই নিউক্লিয়াস টু পৰা ডিসটেন্স এই নিউক্লিয়াস টু পৰা ডিসটেন্স বেলেগ বেলেগ আৰু ডিসটেন্স টু যিমানে বেলেগ হ'ব সেই পটেনশিয়াল এনাৰ্জিটো কি হ'ব বেলেগ হ'ব তাৰ মানে এই ইলেক্ট্ৰন টু পটেনশিয়াল এনাৰ্জি আৰু এই ইলেক্ট্ৰন টু পটেনশিয়াল এনাৰ্জি এই ইলেক্ট্ৰন টু পটেনশিয়াল এনাৰ্জি কেতিয়াও সেম থাকিব নোৱাৰে আৰু যদি পটেনশিয়াল এনাৰ্জি সেম থাকিব নোৱাৰে the total energy is also not same so কি বুজিলো ইয়াত since all these valence electrons are more or less influenced by the other nucleus of the silicon atoms their respective potential difference may be different will be different so as a whole each of these valence electron will never possess the same energy প্ৰত্যেকটো ভ্যালেন্স ইলেক্ট্ৰন ইয়াত যিমানটা ভ্যালেন্স ইলেক্ট্ৰন আছে নহয় সো প্ৰত্যেকটো ভ্যালেন্স ইলেক্ট্ৰনৰ এনাৰ্জি অলপ হলেও fraction of a second or fraction of karne holo fraction of amount holo change they will never be same suppose example dilu ei prothom to 0.001 electron volt like just example dilu ei electron to suppose man na lage 0.01 electron volt as for example ei second electron to suppose this is the second electron ei second electron to potential energy ketia same hobo nore yat ki olop holo belag suppose 0.02 electron volt for example similarly this electron will also valence electron will also possess a different energy suppose this is 0.03 electron volt etuke ami ki kobo bichaisu suppose a crystal total number of n atoms as in this particular crystal there are total number of how many atoms n and we know each atom possess 4 valence electron so now tell me what is the total number of valence electron in this crystal the total number of valence electron in this crystal is 4n. Why? Each of the atom possess 4 valence electron, and the total number of atoms in this crystal is how much n? So total number of valence electron in the crystal will be 4 into n. And each of these 4n electrons will all have different energy. Why they will have different energy? Because each of these valence electron are more or less influenced by all these nucleus কাখত থকা নিউক্লিয়াস বিলাকে ইনফ্লুয়েন্স কৰিব আৰু সেই নিউক্লিয়াস বিলাকৰ ডিসটেন্স টু কম বেছি পৰিমাণে বেলেগ বেলেগ হ'ব সেই কাৰণে each of these 4n electrons will never have the same energy okay so this all have different energy গতিকে সেই এনাৰ্জি বিলাক মই এটা গ্ৰাফৰ জৰিয়তে প্লট কৰিম প্ৰত্যেকটো 4n ইলেক্ট্ৰনৰ এনাৰ্জি I will try to plot in the form of a graph এটা গ্ৰাফটো তুমি কেনেকৈ চাম চোৱা this is the suppose as for example suppose this I am taking as the suppose this is the energy level or this is the amount of energy possessed by the first electron as for example prothom electron to suppose 0.01 electron volt tak dekhabo karone I have drawn this as the energy level okay এতিয়া সেকেন্ড যেটো ইলেক্ট্রন হবো তার ডেফিনেটলি পটেনশিয়াল এনার্জি 0.1 অতকে বেলেগ হ'ব হয় বেছি হ'ব বা কম হ'ব সাপোজ মই ধৰিছো 0.01 0.02 ইলেক্ট্রন হ'ব গতিকে তাৰ এনার্জি লেভেলটো 0.01 অতকে অলপ হলেও ওপৰত থাকিব এইখিনি মত থাকিব so this is the energy level of the second valence electron it was up to ultimately valence electron so this was the first energy level of the valence electron this was the second energy level of the valence electron similarly suppose third electron to it valence electron to it energy level these are all closely spaced energy level tenekwa energy level প্ৰত্যেকটো ইলেক্ট্ৰনৰে বেলেগ বেলেগ যেটো এনাৰ্জি so how many energy levels you can find here 4n number of energy levels গতিকে approximately আমি ইয়াত 4n number and all these 4n number of energy levels will be what different গতিকে so এনেকুৱা এটা band form হৈ যাব all these energy level are different they will form a what band Okay, what is band? It is the collection of different energy level corresponding to valence electrons of this crystal. And this energy level is known as valence band. It is simple bhakat bujhabole gole eneka hobo. This is known as what band? Valence band. And it has got and this it is the closely spaced. It is the what? Closely spaced energy level corresponding to valence electrons of a solid. Valence electrons of a solid. Because it is ultimately valence electron. Okay? So it is a valence band. What is valence band? Valence band is the closely spaced energy levels corresponding to the valence electrons of a crystal or of a solid. Okay? So this is the valence band. Now you see, এটা দেখিলো যে এই গোটেইবিলাক বৰ্তমান ইলেক্ট্ৰন কোভেলেন্ট বন্ডিং হৈ আছে আৰু যেতিয়ালৈকে কোভেলেন্ট বন্ডিং হৈ থাকিব ইহঁতবিলাক আমি ভ্যালেন্স ইলেক্ট্ৰন বুলি কম এতিয়া মই বাহিৰৰ পৰা এনাৰ্জি দিলো সাপোজ ইন দা ফৰ্ম অফ হিট heat or thermal energy. I have provided thermal energy. So as soon as you provide thermal energy, যেতিয়া মই thermal energy দিম এই ইলেক্ট্ৰন বিলাক যিবিলাক ভ্যালেন্স ইলেক্ট্ৰন বুলি কৈছো ইহঁতৰ এনাৰ্জি they will absorb those energy. They will absorb those heat energy by energy, external energy. And as soon as they will absorb this energy, they will gain energy. Energy পাই যোৱাৰ লগে লগে কি হ'ব ইহঁত বিলাকে বন্ডিং টু ভাঙি পেলাব. They will be no longer in a covalent bond because they have gained extra energy. Due to this gain of extra energy, they will ultimately come out from the bonding. Bonding to bhangi pelai enake ulai jaboge. So as soon as you give some extra energy, this electron suppose has absorbed those extra energy, and due to this absorption, they will now come out. They will break the bonding, covalent bonding, and they will come out and will become free. Now this electron is known as free electron. So as more is the more and more thermal energy is provided, more number of covalent bond will break, and more number of electron will become what? Free. Okay? Etia semiconductor ক্ষেত্ৰত কি হয় এটা কথা ইয়াত মই কৈ দিও আৰু in case of if this definitely this is semiconductor because we have used silicon. As soon as a covalent bond is broken, যেতিয়া এটা covalent bond break হয় আৰু এটা electron free হয় যেটো জায়গা পৰা covalent bond break হয় হেতু জায়গাত এটা vacancy create হয়, and this vacancy is known as a hole. You have to remember now. So it is so this vacancy from which an electron has become free, and this vacancy in the covalent bond is now known as what? Hole. And hole is always considered to be having a positive charge. Electron ami khoda ki bole jano negative charge, but the hole is virtually given a what charge? Negative charge. Kintu asole physically it is just a virtual concept. Hole is a virtual concept. From the position from which an electron has escaped, there is a vacancy in the covalent bond, and this vacancy is termed as hole in a semiconductor. So eta notun kotha hekilo je yar eta ki poa jabo eta hole poa jabo, and the charge which is considered for a hole is always positive. Please you have to remember. Okay, eta khona temperature bahalo, heat energy dilu, temperature bahil, so this crystal is gaining thermal energy. Due to this gain of thermal energy, this different valence electron will now become now escape. So they will start to break the covalent bond. Covalent bond blak break hobole arambo hobo, aru jetia covalent bond break hobo electron blak free hobole arambo hobo. As soon as an electron becomes free, this place will be occupied by a what? Hole. Eta electron free hoy gol, eta ebla free electron. So number of free electrons and holes pair can be created by increasing by supplying energy, thermal energy. Maybe the energy is in the form of thermal energy. Okay? So electron hole pairs are created in a semiconductor by the application of thermal energy. So thermal energy di dilu, thermal energy boli likhi disu, thermal by heat energy supply korar loge loge covalent bond blak bhangibole arambo hoise, aru jetia covalent bond bhangibo free electron release hobo logote eta hole pam, and this particular happens in the material which is semiconductor. Okay, now you see etia soa je এই ইলেক্ট্রন যেটো এতিয়া বৰ্তমান ফ্ৰী হৈ গল, কেলে ফ্ৰী হল? because it has got energy. যেতিয়ালৈকে covalent bondত সোমাই আছিল যেতিয়ালৈকে কোভালেন্ট বন্ডত বাইন্ড হৈ আছিল তেতিয়ালৈকে তাৰ এনাৰ্জিটো কিমান আছিল 0.01 as for example কিন্তু যেতিয়া হি ফ্ৰী হৈ গল এবাৰ কোৱাচোন ইয়াৰ এনাৰ্জি 0.01 হ'ব নে 0.01 তকৈ বেছি হ'ব ডেফিনেটলি বেছি হ'ব because it has gained energy so now this free electron is definitely having some energy greater than 0.01 okay গতিকে এই ইলেক্ট্ৰনটোৰ এনাৰ্জি লেভেল যদি আমাক আঁকিবলৈ দিয়ে ক'ত থাকিব ইয়াত থাকিব নে ইয়াতকৈ ওপৰত থাকিব ডেফিনেটলি ইয়াতকৈ ওপৰত থাকিব এইবিলাকটো হ'ল ভ্যালেন্স ইলেক্ট্ৰন আৰু ভ্যালেন্স ইলেক্ট্ৰন বিলাকৰ এনাৰ্জি সদায় ফ্ৰী ইলেক্ট্ৰন বিলাকৰ এনাৰ্জিতকৈ কম হয় সো ডেফিনেটলি এই ইলেক্ট্ৰনটোৰ এনাৰ্জি লেভেল এই বেণ্ডটোত নাথাকে ক'ত থাকিব অকমান ওপৰত থাকিব ইয়াত থাকিব suppose this is the first energy level of the first electron এটা example দিছো similarly second electron of free hole গতিকে ইয়াৰ ডেফিনেটলি এনাৰ্জিটো ফ্ৰী ইলেক্ট্ৰন এনাৰ্জিটো ইয়াৰ সমান নহয় ইয়াতকৈ বেছি বেলেগ হ'ব বেছি হ'ব বা কম গতিকে তাৰ suppose energy level এইটো this is the energy level of the second free electron বা conducting electron okay so this is the third energy level then again fourth energy level so there are numerous number of energy level can be formed numerous number of energy level infinitely number of energy levels can be formed and all this energy level now corresponds to which electrons this conducting electron or the free electron and this collection of energy level or this band of energy level is known as conduction band okay so আমি আৰু এনেকৈ দি দিব পাৰো এটা আজ দিছো মানে কি যিমান ওপৰলৈ যাম এনাৰ্জি লেভেল বিলাকৰ এনাৰ্জিটো বাঢ়ি গৈ আছে so this band is now known as conduction band which corresponds to the free electrons and this is the energy level that corresponds to valence electron our free electron আমি কেতিয়া পাম যেতিয়া covalent bond break হ'ব so this is actually the concept behind energy band in a solid so there are basically how many types of energy band two types one is conduction band and one is valence band okay acha next কথা now you see as soon as thermal energy is supplied an electron a covalent bond will break and the electron will become free the electron free hobo and the vacancy will be created which is known as a hole in case of a semiconductor now this free electron as soon as it becomes free before this electron was binded in a covalent bond its energy was somewhere here the energy to a2 level asile as soon as it has become free the electron has jumped from this position to this position okay so here there is a hole and this now electron has gone here now this is a what free electron or a conducting electron so a electron to hoy ya ba yale jump koribo lagibo ba ya ba oporle kintu ei jagakonot ketio thakibo noare বুজি পাইছানে এই জায়গাখনত ফ্ৰী ইলেক্ট্ৰন কেতিয়াও থাকিব নোৱাৰে গতিকে এই জায়গাখন ফৰবিডেন হিয়াৰ দ্য ইলেক্ট্ৰনছ ফ্ৰী ইলেক্ট্ৰনছ আৰ নেভাৰ এলাউড টু বি দেয়াৰ সো দিস ইজ দ্য ফৰবিডেন ৰিজন আৰু এই গ্যাপটো যেটো গ্যাপ পাম ইয়াত কণ্ডাকশন বেণ্ড আৰু ভ্যালেন্স বেণ্ডৰ মাজত এই গ্যাপটো কয় ফৰবিডেন এনাৰ্জি গ্যাপ সো EG is known as energy gap or in simple way you can known as they are also known as energy gap this gap so in this gap why it is known as energy gap forbidden energy gap because this region is forbidden for any free electron either the electron should be here or here when it is a valence electron its position is in the valence band as soon as it becomes free its position will be in the conduction band the electron can never be in this region so this region is known as forbidden region and the energy difference of this two band etu ki boli koi asalte EC mane lowest level of conduction band and this is the highest level of valence band and the difference of this level ta mane EG ame ki hobo paro EC minus EV highest level of conduction band and the lowest lowest level of conduction band and the highest level of valence band the difference of these two energy level is known as energy gap and in case of silicon Jodi a semiconductor to this material is suppose silicon this energy gap is 1.1 electron volt more rakhibo lage and suppose in place of silicon we have taken germanium then the energy gap will be 0.373 electron volt like this approximately 1.1 electron volt in case of silicon, and the energy gap for germanium is 0. Tamane silicon atom eta valence band of silicon atom etar valence electron free koribo karone minimum kiba energy dibo lagibo 1.1 electron volt. So ইয়াৰ পৰা ইয়ালে তেতে জাম্প কৰিব ইয়াতকে কম এনাৰ্জি পালে এটা ইলেক্ট্ৰন সিলিকনৰ ক্ষেত্ৰত সিলিকন এটমৰ ক্ষেত্ৰত কেতিয়াও ফ্ৰী হ'ব নোৱাৰে so minimum it has to get this much amount of energy then only the electron will break the covalent bond and become free and in its place there will be a hole eto eta hole thaki okay so this is the concept of energy band in a solid and this energy band can now be used for 3 different types of solid which is conductor semiconductor and insulator prothomote ami sam in case of number 1 conductor khetrot energy band to keneko eti ami janu je eta conductor suppose eto ta conductor now in a conductor there are maximum number of electrons are already free tamane maximum number of tamane it is very much easy to free an electron in a conductor valence electron eta conductor khetrot free koribole tene khos mane in case of conductor the gap is very very small karon electron ta easily ame free kori dibo paru small amount of energy dile ই ইয়ালে গুছি যাব কারণ ইয়ালে গুছি যাব মানে কি এই গ্যাপটো কম গ্যাপটো বেশি হলে কেতিয়াও if the energy gap is more energy will be required to free an electron but in case of a conductor the electrons they need minimum amount of energy to become free otike definitely gap to come কিন্তু দেখা যায় যে আসলে কি হয় in case of conductor there is no gap the gap is almost zero or in other words you can say that the valence band and the conduction band are partially overlapping suppose etu eta amar conduction band ei tolor to amar valence band ei kini jaga overlap hois overlap ho mane ultimately hator kuno gap nahi so valence energy gap is almost zero so it is very much easy to free an electron from valence band to covalent bond because the energy gap is almost zero so it is very much easy so this is the case for conductor so what you have to remember in case of conductor the valence band and the conduction band are partially overlapping or in other words what you can say the energy gap is zero energy gap to almost zero etia number 2 in case of insulator ki hoy jodi moi insulator material ta lo insulator ako ki hoy it is very much difficult in case of insulator to free an electron eta valence electron eta free koribo karone insulator material khetrot bahut beshi energy lage aru beshi energy lage mane ki je a gap to difference the valence the energy gap the size of the energy gap should be very large so jodi mo energy band diagram to banao ki hobo etu jodi valence band hoy conduction band to gap to both basic suppose this is the conduction band and this energy gap Eg is said to be greater than 3 electron volt in case of what insulator the energy gap between conduction band and valence band is said to be greater than 3 electron volt so very huge amount of energy will be required to free an electron from valence band to conduction band and hence which know that in an insulator there are no free electrons or very 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 less amount of free electrons which is not at all possible for conduction otike etu karone ami ki kom je gap to bahut beshi so third case which is an insulator semiconductor eta mo koisu already semiconductor khetrot ki hobo energy gap to definitely yatke beshi kintu yatke kom hobo so the energy gap in case of semiconductor is actually less than 3 electron volt in case of silicon it is 1.1 electron volt and in case of germanium material and it is 0.73 so different semiconductor material will have different energy gap but all those energy gap is less than 3 electron volt so jodi mo akibole di enako hobo so this is the suppose valence band This is the valence band and this is the conduction band. The gap to the here অকমান কম আৰু কি লিখি দিম ইয়াত যে Eg energy gap is less than 3 electron. So this is conduction band. Hey. Okay. So next what you have to remember, for silicon the value of energy gap is how much? 1.1 electron volt, and in case of germanium the energy gap is 0.74 by 73 electron volt. And for different type of semiconductor material, this energy gap will be different, but it will be less than 3 electron volt. So this is all about energy band in a solid. This is all about energy band in a solid. Okay. Now, after this, we can now discuss about semiconductor. Now, we shall be now discussing only about semiconductor, in which we have learned that the energy gap between conduction band and valence band is less than 3 electron volt. So now the semiconductor which are naturally formed, that are formed naturally in our nature, in our day-to-day life, those are known as intrinsic semiconductor. Jiblak semiconductor I mean naturally found, those are known as intrinsic semiconductor. Intrinsic semiconductor. Jitu already agate moi bujaisilo, etu asolতে এটা intrinsic semiconductor আছে. Jitu already moi explain কৰিছিলো. As for example, silicon, germanium, all these are intrinsic semiconductor. This has been provided us naturally. So already I have told you that the silicon, germanium are tetravalent. So they have 4 valence electron, and if they form a crystal, the crystal structure is like this. Already called, it has got 4 valence electron. Okay. So when they form a crystal, they share the valence electron with the neighboring silicon atoms, okay, which is also known as a covalent bond. So covalent bonding kore. So this is the valence electron. It is silicon again. This is the valence electron of all this. So according to octet rule, to gain stability, they will share this neighboring electrons, valence electron, and which is known as a covalent bond. So all these electrons are now forming covalent bonds. And a covalent bond form kori ase kakhot thoka silicon atom boror hoite. Eneke moi dekhai disu. Okay. So this is a atomic structure of intrinsic semiconductor which has been formed naturally in our universe. Now, what will happen if the temperature is at absolute 0? Jodi a particular crystal to my absolute 0 temperature thoi disu. Tamane when the temperature is equal to absolute 0 Kelvin, what will happen? We know that at absolute 0 temperature, all the electron motion will cease to occur. Kuno electron motion nathakibo, or this electron will have no energy. That means all these covalent bonds are intact. No covalent bond will break. Kuno etao covalent bond at crystal to break nohoy. Aur jodi covalent bond break nohoy, tetia ketia electron free hobo nohoy. So, and if there is no free electron, this semiconductor will behave like a what? Insulator. So what happens at absolute 0? A semiconductor or an intrinsic semiconductor completely behaves like an insulator. Why? Because at this temperature, none of the covalent bond in the crystal will break. And if covalent bonds does not break, free electrons are not generated. Electron hole pair will not be generated. Okay? So this is the first thing you have to learn. So if you are asked to draw the energy band of a semiconductor at absolute 0, so what will be the diagram? So this is the valence band and this is the suppose conduction band of our semiconductor. Okay, so this is the energy gap. Suppose here we are taking silicon, so this energy gap will be definitely equal to 1.1 electron volt. ইয়াত যেহেতু আমি সিলিকন লৈছো এই এনার্জি গ্যাপটো আমি 1.1 ইলেক্ট্রন ভোল্ট লৈছো এতিয়া মই ধৰি লৈছো টেম্পারেচার ইজ ইকুয়াল টু 0 কেলভিন so what will happen no covalent bond breaks so there is no free electron since there is no free electron this conduction band is completely what empty conduction band to empty kele কোনো free electron নাই ইয়াত অকল free electron থাকে আৰু ইয়াত কি electron থাকে valence electron all these electrons valence electrons are now lying in the what band valence band so this is the valence band and there are no holes also holes ketia form hoy jete electron ta free hoy এটা electron to free hoy নাই ওতে কোনো hole নাই so গোটে valence electron বিলাক কত হুমাই আছে valence band ত হুমাই আছে আৰু this is empty conduction band is what empty there are no presence of any free electron at absolute zero temperature okay now what will happen if you begin to rise the temperature it is the more temperature bahai diu tamane from externally you are providing heat energy bahale ki hobo temperature to lahe lahe bahi jabo by room temperature koi dilu suppose in this particular room you will have a temperature of 20 degrees centigrade or 25 degrees centigrade tetia ki hobo lahe lahe temperature bahai dia mane ki you are providing thermal energy by heat energy or heat energy power lage lage ei electron bole hey heat energy to absorb koribo or absorb power lage lage yoto energy bahi jabo or bahi jabo jetia this electron will now break the covalent bond and will become what free so as soon as you provide heat energy externally covalent bond will start to break in this semiconductor and electron hole pair kele ya pa electron lai hol ulai jia log log ya vacancy create hol ei vacancy to naam ki boli koa hoy hole aru to ki boli koa hoy free electron so electron hole pair are created as soon as you increase heat energy and at room temperature sufficient number of covalent bond will now break room temperature ki hoy eta intrinsic semiconductor অসংখ্য covalent bond break হৈ যায় আৰু অসংখ্য covalent bond break হৈ যায় মানে কি electron hole pair বহুত বেছিকে create হৈ গল so there are the number of electron hole pairs at room temperature so next diagram if you draw the energy level diagram for intrinsic semiconductor in case of temperature greater than 0 kelvin it is suppose temperature greater than 0 kelvin ba at room temperature boli kobo pari tetia kobo bana ki hobo tetia electron block free hobo covalent bond break hobo electron block free hoy pele yale guji jabo ei to electron free hoy pele so what will get here you will get a hole here and this is a what electron this is a free electron so this is the now this conduction band is not empty yet conduction band of electron khumabole arambho korile karon free electron blak generate hol free electron position to conduction band thake ei free electron aru yat ki thaki jabo hole logote yato electron thakibo balance kan gute bila kon gute bila covalent bond etio break howa nai otike kisuman valence electron etio valence band ot ase otike e free hole yapa yale jabo joa log log yatta hole pam otike kisu porimane yat hole ase aru free electron aru yato free electron hoy hole aru conduction valence electron aru yat ki ase kisu porimane free electron ase so this is the energy band diagram in case of temperature greater than 0 kelvin or we can say at room temperature a to situation this is the situation that happens in case of room temperature okay electrons are now starting to become free free hoy pole conduction band goi ase so we have learned about the effect of temperature so as soon as temperature is increased we are providing heat energy covalent bonds start to break and electron hole pairs are created now tell me in intrinsic semiconductor what happens the number of free electrons and holes are always equal kele eta free electron jetia janmo hobo tar log log ki janmo hobo eta hole janmo hobo in simple way Okay, so here jodi 1 million free electron ase, there are 1 million holes also. So one important relation comes, that is in case of intrinsic semiconductor, is that the number density of electrons, number of electrons per unit volume, number density is equal to number of holes, and this is together known as Ni. Ni to call intrinsic, Ni is known as intrinsic carrier concentration, intrinsic carrier concentration, or the number density of electrons and holes are always equal in case of intrinsic semiconductor. So this equation always holds in case of intrinsic semiconductor, which are naturally formed. I mean, intrinsic semiconductor naturally power equation to hold. Okay.